Okay, hi everyone. I'm Tanya. This is Dom. We're gonna do some data structures and algos today, just so I can gauge the general knowledge here. Has anyone here heard of a hash map? Anyone heard of a linked list? Okay, big O of N notation. Anyone heard of that? Okay, let's just jump right into it. Let's just start with this one. I'm gonna try to introduce you guys to O of N notation and hash maps with this contains duplicate leak code problem. So we're given an integer array nums, and we want to return true if there's any element that exists at least twice in the array. Does anyone know how they would start this off? Anyone have any ideas at all? You want to find out if the same element exists more than one time in the array. Does anyone even any clue as to any kind of method to find out? Maybe use a for loop.
You iterate the array, and then for each element in the array, you create the key as the index.
Oh, so you do know the key of an object, a hash map?
Yeah.
Okay, so you know yeah, so you can basically okay, so but before we get there, I think a lot of people, the way they would try to solve this would be to create a for loop. And when you create this for loop, what is this doing, this for loop? What does a for loop do? What does it do? Yeah, so it goes to the first element, which is 1. It does something. Let's say inside of the for loop, you put, element plus 1, that'll add 1 plus 1, 2, or whatever operation you do to it, it'll do something at that specific element. So it'll iterate over each element in the array and do something. So if we iterate over each element in the array, then one idea that people might have is, we start at 1, and then while we're at 1, we iterate again. And we say, we're at 1, and then we iterate again. So our second for loop, let's go ahead and create a second for loop in here. And you'll understand a little more in a second why I'm creating a second for loop. We don't want to call this I, let's call it J, so we don't confuse the two indices. So when we're in the, we start with the first for loop, the outer for loop, and then the code immediately runs to the inner for loop. So the I in the first for loop is 0, the J in the second for loop is 0. So we have 0 is the first element, right? Because it starts at 0, the index. Yeah. Right. Okay. So I'll get to that in a second. So what we want to do is check to see if nums at I equals nums at J. Why? Because let's say we're in the first iteration of the outer for loop, right? So we're in the outer for loop. Then we go to the inner for loop. Then we check to see if I equals what's at the index of the inner for loop, which is 1. Then we can see if what's at I in the outer for loop, which is 1, equals what's at the second element. And then the third element. So if I equals 2, I equals 3, right? Or nums at I equals 3 equals 1. And then we find that indeed nums at I, which is 0, does equal nums at J at the last iteration. So we iterate twice. Now, like Dom mentioned, the problem is if you start with J being 0, then you'll be checking to see if 1 equals 1, and then you'll be checking to see if 2 equals 2. You always want to start after the I element.
You don't want to grab the same index twice.
Right.
But that's what we're trying to say.
Right. So in other words, what's happening here is if we create some code inside of here which checks to see if the element at I equals the element at J, the way that this runs is it checks, does 1 equal 2? No. Then does 1 equal 3? No. Then does 1 equal 1? Yes. And when that happens, we want to return true. True meaning there is a duplicate in this array. So does anyone know what logic I'd put in here to make that happen? Right. You want remember I'm checking to see if nums at I equals nums at J at every iteration. How do you check that?
Yeah.
Close. If we check to see if I equals J, we're not checking the elements, we're checking the indices. Yeah.
What do you want to do?
So if num z I equals num z j, then we're gonna essentially say, yeah, there is a duplicate here. Return true. Now if this outer for loop runs, right? Just to recap, if anyone's confused, the outer for loop represents, we have one, we're iterating once over here, and the inner for loop will stick with the outer for loop element, and the inner for loop will go this and this, this and this, this and this, this and this. And then when the inner for loop finishes, then the outer for loop iterates once, and it goes again, this and this, this and this, right? So when the outer for loop finishes, right, the outer for loop goes all the way to the end, and we still haven't returned true. What does that mean? It means that there's no duplicate in there, so we want to return false. All right, half the time when I run code, there's always some bug, so oops. Yeah, exactly. Okay, return. Okay, let's submit. When you submit it, it tests it against a bunch of different test cases, not just one test case. So sometimes you'll run code and it works, but then the program will give you another test case and it doesn't work for that one. So you got to submit to see if it works. So this works, but the runtime isn't that great. The runtime means how quickly the code is
How quickly you're getting the results.
yeah, exactly. So so the runtime is better than 13 point whatever. I mean, that's not great. We want to have a higher runtime. So the reason why this is pretty slow is because of something called time complexity, big O of n notation. There's a lot to go into here, but I'm just keep it really, really like simple for right now. Big O of n would be the amount of if you do something at every iteration, then that's big O of n, that's n, right? N is the amount of things in an array when you're doing something in that array. So if we have one for loop and we do something at every iteration at that for loop, it's just big O of n notation. Let's say the for loop has, goes through 10 elements in an array. N is going to be 10 and it's big O of n notation. But over here, we have, in nums, we have, let's say we have 10 elements here. So we have 10 iterations, but at each iteration, we do 10 other ones. So it's 100, it's n squared. So this is big O of n squared, which isn't very fast. We want to get it, faster. Big n squared, that's a lot. That's a lot of operations. So we want to get it as quick as possible. Ideally, we'd want to get this down to, well, ideally, not really ideally, but ideally would be like, log n, but we're not going into that right now. But ideally, we wouldn't want it to be big O of n squared. We want at least big O of n. So this is where hash maps comes into play. Let me see. Oh, not too bad. This is where hash maps comes into play. Like you were saying, we don't want to have a double for loop. Double for loops, the way they work, for each iteration, for each element, each iteration, it does the entire array's worth of stuff, right? So if there's 5, it's an array with 5 things, then you have a double for loop. It's going to end up being 25 operations. At each one, you're doing the amount of elements that are in the array, that many operations. So it's n squared. This has 10, it's going to be 100. Too many operations. So the way that we can get this to be quicker is by using a hash map. All right, so let's go away. Actually, let's not delete the for loop. Okay. Yeah. Oh yeah, I'm missing curly. So we want to have this one for loop, but we don't want to do a double for loop. Too many operations. So what we can do here is create a hash map. So a hash map is really just what you guys know as an object, right? Hash map is an object. So let's call it map. Let's create an empty hash map. And this isn't so intuitive. Necessarily, it's kind of hard to, if you've never, heard of this before, or if you've never done this before, it's pretty hard to figure out. But once you understand it, you realize a hash map is pretty useful and it's not too complicated. So, all right, I don't expect anyone to know, but does anyone have any clue how this might be solved using a hash map? Actually, you do have a clue. Well, what do you say? To push the elements of the array into the map? Yeah, we're checking to see if there's the same element twice for a duplicate, you know. So when you say push it into the map, do you mean like dot push? Is that what that sort of push? That so a map, an object, you know, hash map has a bunch of properties, and each property is a key and a value. So when you say push, do you mean put it as the key or as the value? As the value? Okay, so would each property then have, what would the value be of each property? It would be the element in the array? A set? Yeah. So it's probably a hash map would be better than a set in this case. But what we'd want to do here, what would probably, and there may be, you know, there's probably there's multiple ways to do this, but one simple way to do this is to have an if-else statement. If we hit sorry. All right, first let's create an if-else statement. If something happens, we're going to do something else, we're going to do something else. All right. So we want to check to see, actually, I'll explain it this way. If the map that we create does not yet have the element as the key and the index as the value, then we're going to set the element as the key and index as a value. Let me explain what I mean. So we're at the, where's the input? All right, so we're at 1. We go to 1, where that's the first element in the array. And what we're going to do, since our hash map doesn't have anything in it, it certainly doesn't have a 1 and a 0, right? You know, the 1 would be the element and the 0 would be the index. Obviously, it doesn't have that yet. So what we're going to do, this is going to be in our else, we're going to set the key of the property in the hash map. We're going to set the key to the element, which is 1, and we're going to set the value to the index that we're at. So how do we do that? How do we set the key of an object to something and then the value of that key to something else? Anybody know? How do we do it?
So you it's nums
Nums of I.
equals to nums, or it's supposed to be I.
Yeah. So over here, when you say map at something, right, that means inside the map, there's going to be, that something is going to be a key. So map at nums at I. What's nums at I at the first iteration? It's 1, right? Nums at I at the first iteration is 1. So map at 1, already I'm saying, all right, I want a key called 1. I want a key 1. And I'm going to have equals, meaning equals means I want that value of that key to be I, which is the index. So the first time around, it's going to say, I'm going to take the map, I'm going to make a property. It's going to have the key of 1, the key is going to be 1, and the value is going to be the index, which is 0. So it's going to be 1 and 0. That's the first property we have. All right. Now, as we keep doing this, right, we keep iterating down, we want to check to see if there's a duplicate, right? We just stored the element in the map, and we want to check to see if the next element that we hop to, if that's stored in the map already. Because if it is stored in the map, that means we've got a duplicate, right? So before we get to this else, we're going to check to see if the element that we're at in this iteration that we're at, if it already exists in the hash map. So how would we do that? How would we check to see if this element exists in the hash map? We're going to do something. We want to check to see if the element exists as a key in the hash map. Anybody know?
If and the same thing you have else of map if nums map nums And I have a question, why do we
Yeah.
get value? At all in this case, it's straight true or false.
Yeah, actually, so the reason I put the value, you could put true, you could put false, you could put one. It doesn't really matter what you put as the value. The reason I put the value here is because of the next problem I wanted to do with you guys, two sum, which you do want to have the value in for. But you're right, it actually has. I just got carried away with two sum. You can put whatever you want to the value, but let's just put the index as the value here because it'll prepare us for two sum a little bit. But yeah, you're right. The point is that we want to have the key, the element as the key, right? So what you're saying is map at nums at I. So what does this mean if map at nums at I? It means if it exists, right?
Yeah, because null is false value.
Okay, for some reason, I don't know why this is with LeetCode, but even though this is true, when I run it with this, even though this is 100% correct, LeetCode doesn't like it. I don't know why. So there's another way to do this. You can just say doesn't equal undefined. It's the same thing. And we're going to do that here because for some reason, it doesn't like the if map at nums at I notation. So if map at nums at I doesn't equal undefined, meaning if it is defined, right? If there is a map at nums at I. So same thing. So if it does exist, what are we going to do? Right, we're at, just if anyone's confused, we're at a certain element in the array. Let's say we're at, 1, 2, 3, 1. We're at the last one. And we're checking to see, does map with the key of the element that we're at 1, does that exist? And of course it does exist. We put it in here at the beginning. So if it does exist, what do we want to do? Whoops. Yep. Yeah, my bad. You want to make that bigger? I have no idea. Just like this.
Yeah, there you go.
Okay. Yeah, I did. I totally forgot that about that upper if. Let me see if the brackets are right here because this could be a bit of a mess. Here. Where does what is that? Oh, where does this end? This isn't good. All right, this one ends here. Nope, that's not good. It should end here. Where am I missing a bracket? If someone want to help me out, where am I missing a bracket? Oh, is this good? Right here. And this for loop should nope, that's not good either. This is the most annoying thing. Anyone know where missing or adding one too many? Line 10 too many. Else here. Oh, I think there should be another one here. No, but then why is for loop? Why is that for loop ending there? Nope, that's not good either. All right. This finishes this. All right, this we want this to be this one, but it's not. No, not because look, this should end the for loop, but it's not ending the for loop. Else map and nums at I. Oh, is it this guy right here? Yeah. Oh, you just indent this whole thing.
Yeah, I'm looking at.
Where this looks fine to me right now. Oh, now we do need one more here. Oh, there we go. Okay. All right. Yeah, that is the for loop. That is that. Okay, perfect. Okay, so if we do find a duplicate, what do we want to do? Return true. I'm going to finish up. So we find a duplicate, we return true. Now this is one for loop, right? We don't have a double for loop. This is good time complexity. It's only one for loop. So let's say we go to 1, 2, 3, 1, we finish it and we still haven't, this still hasn't returned true, which means we still haven't found it. We want to return false, right? Let's just zoom back out to see that. There we go. Okay, so this works the same. I mean, this gives you the same result, but as you can see before, the time complexity was 13%. Now it's 41.99%. So that's a lot better. Yeah, that's going to be it for now. We're done. Oh, questions? Yeah. That's the. Yeah, well, it's the same. It's a variable in which the function is stored, but I didn't create that. That's just LeetCode, which gives you data structure algos. They provided that, and they told me to solve the function. Yeah. Yeah. So let me actually knock it. I shouldn't have done this because let's just set it to 1, right? Let's set it to if map at nums at I. It doesn't matter what we said. I just don't want to confuse anyone. Doesn't matter at all. Right. So you're right. At the beginning, it's empty, right? So in the beginning, there's no way it's going to return true. Because you can't have a duplicate at the first element. It's impossible. You have to bin over. Yeah, so you fill it up. Now, if the first 2 elements are the same, and the first time it's going to be empty, it's not going to turn true. And the second time it's going to say, oh, I found it. Turn true. Oh, nums is the input array. So it's 1 time. Yeah. Yeah.
And we're checking if
So every time, basically, this, which is the quicker way to do this, the optimal way to do this, every time we land at an element that we haven't landed on yet, we're gonna take our map, our hash map, our object. We're gonna set the key to the element that we're on. Let's say we're on a 2, and we've never landed on a 2, right? We're gonna set the key to a 2, and the value, it really doesn't matter. We just need to have a key because that's what we're checking. So then when we go to the next iteration, let's say we find another 2, then we check. And we're saying to the program, in this hash map, is there a key with the value of the element that we're on, which is 2? And it's gonna say, yeah, we were there 2 iterations ago. Return true. Okay, sure. Do you want me to just go to? All right, should I pull that up?
Yeah.
Whoops. Oh. Hope.
All right.
Yeah.
I'll go over it.
Wait, what's
Like, all right. So.
Why is there? What's going on with the internet? I didn't see anything.
All right. All right, guys. How many of you guys have done reverse a string here? No? You did reverse a string?
Yeah.
Like, how would you do it? Or how did you do it? Like dot reverse?
I put a forward and made it happen.
Iterate backward. That's also a good way. And then you sort it within an output, right? An output array. But what happens if, like, in this problem, they're telling you, we don't want you to create a new space. We don't want you to return a different array or a different output. We want you to do it in place, like they do on line 3. So that would probably be the most optimal in time, right? Because we're doing it in place. But what does that mean? Any ideas? No. It is a loop. We do have to do a loop, but we don't want to create new space. Mm-hmm.
Just making one array.
Exactly. So we want to. Did I say time complexity was bad? I meant to say space complexity. Yeah. So we would do something like 2 pointers, right? And 2 pointers is pretty much straightforward. We set up 2 pointers, end, front, and ultimately we will be switching the values, but holding the same index. So that's the index will be the same, but the values that they hold will be swapped. Right? Does that make sense? Cool. But there's a little trick on this because also when we do that, we lose a bookmark. So like, let's say I set the left pointer to hold the value at the right pointer, but now the right pointer has no way to like know what the left pointer is, right? We lose that bookmark. So we would have to do like a temporary variable that holds that value. So if we start off by saying And I want to walk you guys through this because sometimes, for me at least, when I do an interview, I don't really jump straight into the code. I think about it. I'll tell the interviewer, listen, give me a few minutes. I gotta think about it. I'll talk out loud, and then I'll like pseudocode it, because when you pseudocode it, you don't have to think again. And you're not thinking about code. You're thinking about, okay, it's already written for me. I just have to follow the steps I already wrote. So here we would say let right equal 0, left equal s dot length. Let me make that bigger for you guys. Dot length, and then I want to say temp equals. Well, temp we're not going to really assign a value just yet, right? Because we'll do that within the for loop, within the while loop. Excuse me? So that's going to be the bookmark. That's like a temporary value. Does that like look weird to you? No?
Makes sense how I compare it.
Okay, cool. So I would say, what do we want to say? What do we want to ask here? What do we want to like continue doing as long as whatever this is true?
Right?
Create an empty array? No, there's no wrong answer to this.
But, you-
Yes,
Until you get to.
but remember, keep in mind, we're working with the original array and we're modifying it.
All the points. Claim the length of the array.
Yeah, in a way, because ultimately we did say right is, why did I say right and left are differently? Should have said this left.
Or something related to. Either the time machine or the final length of the representation, like the-
Yeah. We want to do that because we don't want to, that's where we want the while loop to end. Otherwise, we'll probably continue to like, we'll get the same result probably. So we're doing this and we're coding out and we're saying, what do we want to set temp to? We want to set temp to s at left. Right now we have our bookmark. Now we know if we console log, right? If we console log left, I'm sorry, not left, temp, and we run this, we should be getting, all right, not really used to like using Macs. We run this, we should probably be getting 0. Actually, not 0, the value. Oh wait, I just went into for loop, an infinite loop. And the reason being is because of the while loop. So I'll console log that in a minute. And then the left, so we have our bookmark, and now we want to say the left, right? And we want to reassign the left value, but we don't want to move the index of the left. So we're gonna go ahead and say left equals s at right. Now we just swapped, right? Now we just swapped the value. And because we have our bookmark, now we can go ahead and confidently say, whoops, not that. You can confidently say right equals s at right. Sorry, temp. So now you see how we needed that temp, that bookmark. But we also want to make sure that we keep moving these indices because we don't want to like stay forever at the same place. So now we go ahead and say, what do you think we gotta say? follow that thought. You were saying, yeah, increasing this. So we want to say left plus plus, and then right minus minus, right? So if we run this, we should be able to get, and that's the ultimate, that's the infinite loop. That's why we got the H. Hello. Oh, that's because we're probably not turning something, but our output, what is here? What's wrong here? Left plus plus, right minus minus. Are we not doing this? Hmm. Yeah, because we did this, did that, and while left and right, we want to return? Don't have to return. Oh, is this what it is? What's wrong here? Second. We set our tempi to the left. We set our, oh, is that what it is? Let's see. Right, left plus, right minus minus. What are we getting here? Let's console log. What are we getting? We're not moving stuff. Why are we not moving? Oh,
I said left, I said right.
I said left.
I said left, I said right, not. You're doing left, I said right, but you can be right. I said left, okay.
I said left. So you're saying left at S?
No, it's gonna be left, I said left. Oh, it's in the pen, it's more than here, and then-
This. For left plus plus. I see it right.
Yeah, write it down.
Okay. Oh, that's why. That's why. I never really specified here. S at left and then S at right. Mm-hmm.
And then I said left is.
There we go. That should be fine now. Undefined, okay.
I said right should be 10 to 9. I said.
There we go. Undefined, so we're almost there. Why are we not getting this? The only value that we're missing. Are we sure we don't want this?
Oh, because you started, it should be, the right should start at S dot length minus 1.
Yeah. There we go.
It's much easier to visualize this one.
Yeah. All right. So my problem was the fact that I forgot to specify exactly what I want to move. So that on line 9 and on line 10, I forgot to put as bracket left, because what I've been trying to say from the beginning is we're trying to move around the values, not the indices. I was trying to move the index with the value. Obviously, that's going to give me a wrong answer. But that's also a big mistake that can, be frequent with even any coder at any level. You can always forget something very small. And like the -1, that happens to anyone. I've gone through that through interviews as well, and like maybe like I'll forget the -1. Very small details. Sometimes we just have to pay a little bit more attention. but you guys understood what the concept was? Yeah, I see a lot of nodding heads, that's good. Glad. But yeah, that's ultimately what they're asking us to do. Just don't create any more space. We want you guys to do it in place, and then we want you to we also achieved, I believe, a faster runtime because we're not iterating more than once, you know? Yeah, I guess a for loop would also do the same thing, but yeah, that's it. You wanna do,
Yeah,
go for it.
I'd love to get the linked lists eventually, but we don't have too much time. List, I'm gonna try to do something to hammer this home because it's a linked list. Okay. Would you guys rather focus on the same hash map concept and the OVA notation or try something new? Try something new? Okay. All right, for the linked list, when I was trying to learn this, I was looking on YouTube and a lot of people teach it like not visually. And I think if you don't teach it visually, I think there's no way. It's hard. This is a similar concept actually with talking. What? Really guys have not done it, right? Yeah. A link list. Okay, real quick, what is a link list? Does anyone know what a link list is? You know. Right? Oh.
It's like, keep my head in the.
Yeah. Is there another one? This one's kind of garbage. Is there another one? A linked list has a bunch of nodes and the nodes are linked together, thus the term linked list. So a node has a value in it. So it has a number, let's say number 2, okay? There's 2 properties. This node. It has a value and it has a next property. The next property is everything that is attached to the node going forward. This is a bunch of nodes here. The next property has all the other stuff in it. So it's got a value and it's got a next property, kind of like an object. It has them. It's got 2 properties. Oh, but then you have to write with the mouse pad. I think that's. Okay, so. Oh, yeah. Okay, so each node has a value property and it's got a next property. The next property has all the other nodes in it. Okay. That's what a linked list is. Pretty simple. So it's kind of like, if you think about it, it's structurally it's the same as a nested object. Right? Imagine an object, and that's the bracket, and it's got it's got 2 properties. It's got the value, the v, and the value in the node is what 2, and then the next, let's call it, that has a bunch of other objects. And the object inside of it has a value property and a next property, and that next property has another object, right? It's like a nested object, structurally it's the same. Okay. Exactly. No, the structure is similar to a nested object is what I was saying, but each node has 2 properties. It has a value property, which is what's inside that, it could be a letter or a number like this. So it has value. So it looks like this. This is how it looks. You see how they're linked together? So this is when it says, I think there's a next property that creates that link. This is next after this, so it creates a link. Whatever is in the next property is next. Is next in line. Yeah. So 2, 5, hello, whatever. These are all the values, right? So the value of this one is 5, and the next property is this node. And this node has the next property of the next, right? So each node has a value and has a next property. The next property just contains all the other. So actually, I'm looking to put that back. what we want to do, this is like the archetypal linked list problem, is reverse linked list. We want to, doesn't matter what the value of them is. We want, right now the list is going this way. This dot next, right? Because dot next is not dot next. This dot next is this, and this dot next is this. This dot next is this, right? We want to reverse it. We want to have, this dot next not be this. We want to have this dot next be this. So we want the arrows pointing that way, right? We want to reverse. Let me go to the leak. We want to reverse a linked list. Okay, so it looks like this. Actually, this is a perfect representation. 1, 2, 3, 4, 5. We want it to go 5, 4, 3, 2, 1. Right? We want to reverse the order of the linked list. Which time we have? 15 minutes. Okay.
For us to do that, we have to, like, it's not just moving around. We do have to do like a pointer kind of thing, but we also have to make sure that the arrows do reverse. So like we could move one arrow and the rest of the links broke off. So now we have two items of links, nodes. And we want to avoid having a total break from each one of them.
And you'll understand that more clearly in just a minute. But what we're given, okay, so we want to return it. We want this dot next to be this, not to be this, right? We want this dot next to be this dot next. We want to reverse the order of the linked list. So what we're given is the head of the linked list. Starts right here. This is the head, right? And the head, if I console log the head, it would print out this whole thing because the head contains this, which contains this, which contains this. So we print out the whole thing, not just the first node, right? The first node has the second node, which has the third node, and so on. So we're given this head, and our strategy is going to be to iterate through this linked list. And every time we jump to another one, we want to take this. This is going to have a dot next property. What is the dot next property right here? What's in that dot next property? Anybody know? What's that? Yeah, it has a next property. So what's inside this node's next property? This one, right? What we want to do when we're here, let's say, we want what's inside this next property not to be this one, but to be this one, right? Whatever's next is literally next in line. We want that. That's how we reverse it. Right, is that clear, everyone? Yeah, we want to reverse. Yeah. So when we get to any node, this dot next will be this, but we want to change it to be this, right? But if we do that, right? Let's say we're right here, and we say we want to take this one, and we want this dot next. Let's call it current, right? So actually, let's make a variable called current, and we're in the beginning we're going to set it to the first one, the head, current. All right, cat, that's not a thing. So let's say we're at current, and current is right here. Right now, current.next is this one, right? We want to say current.next equals this one. But the problem with that, anybody know the problem with that? Anybody know the problem? If I'm right here and I say current.next is the previous one. What's the problem if I do that? You want to figure it out? Not exactly, but let's say we do that. So we say this dot next is this one. So we take this arrow, right? This arrow is pointing this way. We take it and we say no. We want it pointing this way. Well, the problem here is now that we have it pointing this way, and more cleanly would be written, we broke off like that. Now it's written that way. How are we going to hop to the next one and do the next iteration? It's broken. This broke off. And that's what Don was talking about when he said we need to set a temporary variable at temp and put it over here so that after we break it off, we still have some connection to the next node so that we can hop to temp, right? We're going to set current, which is right here, to here. We're going to set it to next. And then now we can do it again. We can say current, I want to point it that way. If we didn't have a next variable here, we'd have no connection. It's broken off. right? How do we take current and make a hop here? We wouldn't be able to. So we saw that the found thing with a temporary variable. We're gonna call it next, or temp doesn't have a in the beginning right here. So we start off. We have a current, and we're gonna set it in beginning to head, right? So current first. C for current. It's gonna be right here where the head is, right? We also, like I just mentioned, we want to have a next variable, right? A temp, a next, whatever you want to call it. We can just call it next. So let's make a next variable. We're not setting it to anything because we're just going to use it later. In the beginning, it's nothing, right? We also do want to have, I don't know if you guys remember, but I mentioned that we want to take this and set current.next to what? That's current.next is now this one, but we want to set current.next to the previous one. Let's call a variable previous. And in the beginning, what's previous going to be? Previous is the one before this. What's previous going to be in the beginning? It's going to be nothing. It's going to be null, right? Beginning, it's going to be null. Just make sure the time to let prev. Let's call it prev. No. Okay. So let's say, let me ask you guys right now. Let's say I have 2, 5, 9, or I don't know. What is, if I console log right now, current dot next dot value? What is that? What would I get? 5. Current to this dot next to this one dot value, the value is 5. What about current dot next dot value? 9. Right. Okay. So previous right now, I didn't really leave much room, but previous is over here. It's null. There's nothing. I mean, previous is nowhere. Right? Previous is null. It's nothing. What we want to do is at each iteration, let's say we're here, we take this one, we set the dot next, which is right now pointing this way. We set the dot next to previous, to the one beforehand, right? And then we hop the current over to the next iteration before next is set. So we're going to keep doing that. At every iteration, we need some. What do we need when we iterate over something? What do we need? Like, how do you iterate over something? A for loop. In this case, we'll use a while loop because we're not using indices, and we can just say we just want to do something while,
While something is true.
Yeah. In this case, this is a bit tricky. I don't want to overcomplicate this, but actually, I will overcomplicate it because I have 10 minutes left. We want to keep, what do we want to keep doing this until what? As long as what, right? Current is going to be here, next is here. Then we're going to move current to next, and it's going to be current and next. And then we do it again, and we keep moving over. And now let's say current and next. Now this is current. We do that. Yeah, so while current is null, so current here, and the next is over there. And now we want to do this again and then stop after that. Then current goes here, we're off the board. So initially, one might think,
Until previous is null. Until previous is not, while previous is not null.
so let's do while current isn't null. So here we're going to keep doing whatever operation we're doing, that we talked about. We're going to do it as long as current. Yes, I don't tell this. I don't want them to hear. As long as current isn't null, right? As long as current is still a node, a valid node. As long as current isn't null, we're going to keep doing this thing that we talked about that we're going to do, setting the dot next the other way for that one, previous. Okay. So right now, I mentioned we set current to the head right here, right? And before we reverse the arrow, we want to make sure that we have a next variable on what's currently the next node, so that we can still have a pointer, we can still have some connection. Let's go ahead and set the next right here. From the code, we just write next. Where is it going to be? Where do we want to put next? Where did I just put it? Current.next, yeah. Next, we're putting it on current.next. So whenever you see .next, that just means where whatever's before .next, in this case current, where current is pointing to. So when you see .next, just think is pointing to. So current dot next, current is pointing to, right? It's pointing to here. So this is current dot next. Dot next is pointing to, same exact thing. Okay. So we've set the next variable like we need to. And now we want to, what do we want to do now? So we've set that, the problem was, we don't want to, disconnect the links. But now that we have a next variable here, now we can do what the whole point of this is to do, reverse the dot next, right? So what are we gonna do with current dot next? Right now, current is pointing here, but what we want to say is current is pointing to previous, to null. How do you do that? Well, yes, exactly. So current is pointing to, dot next is pointing to prev, which right now is null, right? Okay. Now what we want to do, now that we've essentially done this, right, we're pointing it to null. This is null. That's null, everything was null. Now we reverse the order of this, right? Now what do we want to do? We want to hop to the next one. Current was here, but now we're done. We did what we need to do at this iteration. We're done with it. We want to hop to the next one. We want to take current and we want to put it here. How do we do that? What's that? But what is current dot next right now? Current dot next is null now, right? So, so what's the point of putting the next current dot next? We remember we put this here for a reason, so that we can hop from here to here. We still have a connection. Hold on. Yeah, actually it was in reverse order, but yeah, exactly. So current equals next. We want to set current to next. We want to set current right here. So current is going to be set to next, right? One equal sign just means is set to. Okay. All right. So now we've hopped to the next one, but previous is not really previous. It's two previouses, right? We want to make previous be the previous one. So how do we do that? Exactly. Previous, we're going to set it to, sorry, hold on. Right. So I confused you guys a little bit. My bad. But before current was over here, let's say current from here. First, we want to set previous to current. We don't need to, right? And then we want to set current to next. So it's just the opposite order.
Are you guys following?
Yeah.
Yeah, okay.
Okay. So we yeah,
It-
so
yeah, the order matters a lot.
yeah.
You want to learn recursion?
What is it?
Oh, we could do recursion. We could do recursion on. a
Oh,
lot
you
of
could do
stuff.
this? Yeah, yeah.
But
But
if you know
I don't
recursion,
think you
like
want that today.
we just started hitting recursion and it's like super difficult.
You get it doesn't.
But just so you guys can have an idea, if you guys don't know what recursion is, it's basically a function calling itself within the function.
So, all right, we just finished one iteration. Now we have current here, the next here. Now we're gonna do it again because current is still not null, right? So we're gonna do again. We're gonna take next and we're gonna put it on current dot next. And take the next. We're gonna put it right here. We're gonna put on current dot next, right? Then we're gonna take our current dot next. No, we're gonna take current is pointing to. We're gonna take current and we're gonna point it to prev. The current is pointing to. Now it's pointing here, right? But we're saying current is pointing to prev. We say current dot next is prev right here, right? Then we say we want to take, now that we've done what we need to do, right? We pointed it the other way. We say we want to take the prev, which is right here, put it on current, and current, put it on next. We shift these two over. After we reverse the arrow, we shift these two over. So we take prev, and we put it here, and we say current, right? We put it on next. So prev is going to be current,
Then you set the next, so now current is here. And now, we have this part in reverse, right? We still have this, right? So we're gonna keep doing this until we get to the end. So we're gonna end up. We end up. We're gonna end up right here. With free being on this node right here. And I just realized I'm zoomed, I have no idea what I'm doing. And current and next are gonna be here, right? Now, are we gonna run again when we're right here?
Are we gonna do another iteration? Why not? But current, so we're on line, the code is running through line 16 and it's checking. Does current equal null? Does it?
No, that would be a mistake, but I don't even want to go into why. But no, it is gonna run again, right? It is gonna run again.
So it's gonna run again.
It's gonna set next to current, right, this is pointing this way, the null, right? It's gonna set next over here. Yeah. And then we're gonna set current dot next, current is pointing to this way to pre, right? Then we're gonna take pre, put it where current is. Put it right here. And then we're gonna take current and put it where next is, right there. But current is gonna be over here. Now, what do we want to do? Now we finished the whole thing, right? You can see it's reversed. We're done. How do you return this? I mean, how do you tell the program, hey, I've done it. Here's your reverse linked list. What are we going to return? A lot of people will return current. They'll say, you know, I take in current and I want to return current. Because right in the beginning, current was over here. And I said, if you console log or return current, you would print or you would return the entire linked list. Well, if you console log or print whatever's over here, and since it's facing, the whole list is facing that way, we're gonna print the whole thing. We're gonna, you know, return the whole thing. So what do we want to, before we wanted to return current, because current was here, it was all facing this way, in order to return the whole list. Now, what do we want to return? Now that we reversed it, what do we return? Hmm? Exactly, return prev. Perfect.
Yes.
Exactly right. Let's submit. Yeah, this guy's done a little bit of leak code here. Okay, there we go. Yeah, all right, that's it. 2 o'clock.
Perfect.
Somewhat.
Yeah,
there's gonna be a lot to
This
do.
is not something that, you know, we expect you guys to like understand
Yeah.
off of one problem on the code. You guys probably will like do that and then jump into like other stuff like binary trees.
Yeah, there's a lot. You're gonna have to practice for months, but yeah, as long as you guys practice, you'll get better, you'll be fine. Yeah, Space Guy, are there any quick questions? Because I do have to dip now, but
Yeah, when you guys graduate, like, what's your advice for learning new code and learning these?
good question now. All right, in the beginning, I didn't even know what leak code was. I spent a lot of time not learning leak code, which is a mistake. If you want to get into any good tech company, you have to know leak code. Not any, pretty much any. If you don't learn leak code, you're nixing 90% of good companies, right? You have to be good at data structures and algorithms. Right now I'm using Structy, which is a great platform. Like if you just do leak code, it's going to be really hard because it's like, you know, they give problems to you that you're like, you spend all day on it. I don't know how to solve it. What do I do? Structy is what I'm using now. There's a bunch of these like really good courses, but yeah, find a course that's like really simple, really easy. Do that, then start jumping into leak code problems and just get really good at it. And then you'll be competitive with any CS.
Udemy is also a good library.
Yeah. Udemy has a lot of great courses like the JavaScript masterclass for data structures and algorithms. Cold Steel, yes. Yes, that one's great. So do that, you know.
Don't ever pay for like full price.
No,
Never be full price.
Okay.
Definitely do a lot of leak code. It's super important. I can't stress that enough, really.
No, because like we got it so late that I was already jumping into leak code before I got it. Like, and then you also lose it like 3 weeks after you graduate. So if you really want to use it, you gotta download it.
Wait, what? What
Yeah, you
module?
gotta-
Wait, they gave us leak code after we graduated?
Yeah,
I had no idea.
yeah.
I wish I.
Um,
Couple of them. I've been studying for a couple of months, 2-3 months.
but like these are things that each thing like hash map, Pinterest, binary search, all these things where it's not gonna take you a few months. It's like just 2-3 months. It's gonna take you a little bit more time. You know, you guys coming maybe from non-traditional backgrounds, where
Yeah.
like all this is new. You just learned how to code, and yeah, you're gonna use all these tools in the real world scenario. But realistically speaking, so for you to utilize those tools, you have to get through the interview process, and it's unfortunate that like it's all based off of the algorithm data.
Like I really do want to stress that it really is super important. Like you have great projects, I'm sure you guys all do. But if you look at your project and say, okay, this guy's a bright guy, bright girl, we want him or her as part of our team. But then they're going to give you a hacker rank. And if you don't do any leak code, even though you would be an asset to their team, you're not going to get through that the interviews, So that's just the way it is. And a lot of people decry that and say, well, people are great coders out there. They don't study data structures and algorithms, so they don't get the job. And that's silly because they would be great. That's true, but this is just the way it is. So you got to learn leak code, and it's fun. Honestly, they're puzzles. It's fun to do. So yeah.
And don't burn yourself out. 2-3 leak code's a problem a day. It's like fine, but if you're gonna be doing like 8 hours a day, like you're gonna get bored. At the end of the day, it's like boring. Shit, right? Am I not wrong?
Oh, I love.
Exactly, right? It's like it's not the most fun thing. And then when you're like breaking you're banging your forehead against the keyboard, it's like you want to get away from the keyboard. You want to do something. Like yourself. What's up?
Yeah, good.
Like don't stop your day. Yourself keep going.
So, since we graduated from both institutes
Yeah. We started. We have in Discord. We go over a lot of.
You have like sleepover and shit.
No, don't do that.
So you guys still in the like interview process right now?
So I just finished an internship, where I got the opportunity to like pick up Vue.js, and then I'm also a part-time to see on the pair with the TC platform. So you guys might see me on at any time. Don't be shy. Say what's up. I was at your algorithm session, so it's pretty cool. And then sometimes like I guess this is that also like ask me. So if you guys want to ask anything about data structures, you're not gonna say no.
we just randomly.
Yeah, they just randomly pair you up.
Okay, so-
Usually, like I'll select the student. No, I'll just randomly get paired up, and whatever questions you have, as long as it's not code challenges or projects or portfolios or practice code challenges, I'm good. I'm good to help. I can help you out. I don't know if they let me, but I'll help you.
Okay.
So I make a problem with like, let's say you run like an interview, then when I do some like building with this, they have no idea, or then some.
If you
Google
never
it.
learned it, or they just froze up.
Like if you never learned it, how do you use it?
What you mean if you're in an interview? You mean?
Like you're gonna tell, I would tell them, hey, listen, I've never done this. I'm gonna shoot my shot. This is literally the first time I'm introduced to this topic, and pseudocode it out. And maybe pray to God that maybe your interviewer is nice guy.
You're
Or a nice person.
You'd be surprised. Sometimes you do. I mean, I've recently had you've had this experience recently that you'll do something, code challenge really, really, really well, not perfect, but really well, and you don't get it. And then I've had a couple, months ago, I've had this code challenge where there were 4 problems. I got 2 right, 2 wrong. And I'm like, okay, I failed this. There's no way. And I did get through the next round. So you'd be surprised. You never know.
Weird. Like
yeah.
I applied to JP Morgan. I did the code challenge and I passed it. Regardless of that, I still didn't get in. But there's me passing the code challenge. It just sometimes it's just luck too. Like honestly, you could be like the best coder, but if you don't really get that opportunity, that 1% opportunity of luck, and like you're just still just the best coder, but not really working.
Any
Yeah.
other questions?
Anything like that, you can be skill.
Structure is also pretty good.
Structy's great. I mean, Structy, STRUCT, what, STRUCTY, UCTY.net, Structy.net. That's 60 bucks for a year, but I mean, if it helps you, yeah, it's
It's
worth
good.
it. I mean,
Like, I really like it.
coding boot camps are quite important, so you pay for this one.
Did you, study first before applying to stuff, or did you just?
I did a 5.
I-
I'll still a 5.
I didn't, when I came out, I really didn't know about leak code, so I didn't study anything. I thought it was really very, interviews are very project based and all that, which sometimes is the case, but typically it's not. So no, I don't, first few months.
Are like project.
And then like,
Yeah,
when you, go in for the interview.
So, like, questions that you'll hear a lot very frequently are, tell me about a time, like, tell me about your projects, tell me about the challenges, and tell me the process that you did to overcome the challenges. Don't ever talk about the stuff that you didn't overcome.
yeah.
Like, sell yourself, guys, like, I'm sure, like, you guys have had jobs previously, like, I'm sure your resume is a little extended on the truth at some point, right? Who doesn't extend the truth? But it's not lying if you don't say, hey, like, I had that problem, I didn't overcome it, or I don't even know how to claim that I overcame it. Like, don't make those mistakes. It'll hurt you, and you don't want that. Mhm. I just finished.
And like, is it like?
Difficult? Oh, man, like, so my experience was like for a smaller company, so it was like, when they say they'll never throw you into the fire, that's a lot, they'll throw you straight into the fire. And I hit the ground running, the senior engineer tells me from day one, I want you to refactor the code. And I'm on my computer, I'm like, okay, but what do you mean? Good luck, disconnect, I'm like, what? I don't know Vue.js, I don't know what you mean by refactored code. I'm lost for words. And then like the next 2 to 3 days, like I picked up. Like I learned it. Yeah, I asked a lot of questions on my coworkers and pick it up. But do expect the worst and hope for the best. What's up?
Sorry?
Did they do that on purpose to me? I thought that, and I told my coworker because he was very knowledgeable on Vue. I'm like, I told him after a while that I thought he worked for the company and he was like a secret intern. And then he's like, no, I just learned it before I came to the internship, and I was confident that it was just JavaScript or React. I didn't know it was Vue, Vue.js, and but they just don't have time for mentorship. Like bigger companies will have time. Like I have friends that work, for example, at Kroger.